Hello students, welcome to Science Extension and Module 1, the Foundations of Scientific Thinking. In this first of a series of 3 videos, I'm going to give you a little bit of discussion around some of the influences that there are on current scientific thinking and research. And what we might do is to split a couple of these up into subparts like I have with other videos, just so they're a little bit easier to digest. In this video, or at least in this little section of videos, we're going to analyse some of the current influences on scientific thinking, including but not limited to economic, political and global influences. And while I give you a little general introduction, I'll actually split those 3 areas up into some small videos as I've done before. And finally, a look at global influences. In his abstract of his 2021 paper, What Drives Global Science? The 4 Competing Narratives, Marginson begins with the following observation. Since 1990, there has been remarkable growth and diversification of worldwide capacity and output in science, and a distinctive global science system has emerged, primarily grounded in research universities, fostered by internet-mediated communication and publication in English, cross-border authorship, and research mobility. While global science overlaps with and is affected by national science systems, it is constituted by pan-national knowledge flows and collegiate collaboration and has partial autonomy. 4 different interpretive frameworks or narratives have evolved to explain global science. Science as an expanding cross-border network. Science as an arms race between competing nations. Science as a global market of competing world-class universities, and science as a centre-periphery hierarchy in which emerging countries are permanently constrained by Euro-American dominance. Whilst the world remains largely divided by language, religion, culture and socio-economic status, in science, communication is becoming more open and collaborative. Projects like those happening at CERN suggest that scientists are working together for the mutual benefit of all nations. This might seem like a naive view, but consistency of language, which is now generally English, standardization of units such as time, length, volume, and so on, naming conventions, the rules of nomenclature, and global problems like climate change are breaking the barriers and encouraging scientists from diverse backgrounds to work together in the pursuit of solutions. 2 interesting contrasts when we look at international science are the international response to the hole, or at least the thinning of the ozone layer, and the modern response to climate science. A good case study of global influence on scientific thinking and scientific thinking on global response can be found in a study of the hole in the ozone layer. This was a significant problem for the Earth, although most significantly felt by those who lived closer to the poles, especially Australians with our outdoor lifestyle. And it prompted global collaboration in the pursuit of solutions such as the Montreal Protocol. Perhaps it was the success of this initiative that prompted an optimistic spirit in the development of the Kyoto Protocols. The Montreal Protocol was ratified in 1987. It was a global agreement to protect the stratospheric ozone layer by phasing out the production and consumption of ozone-depleting substances, commonly used in products such as refrigerators, air conditioners, fire extinguishers, and aerosols. These were known as CFCs. A lot of research was done in order to identify the link between the use of these substances and the decrease in ozone in the stratosphere and the consequent increase in ultraviolet radiation that was reaching the Earth. So serious was this as a global problem that a global solution was found, and nations that had trouble meeting these agreements were either given more time or financial support. It was a great success. The Kyoto Protocol is a treaty designed to assist countries to adapt to the adverse effects of climate change by facilitating the development and use of technologies that can help increase resilience to the impacts of climate change. The International Agreement on Climate Change was developed under the United Nations Framework Convention on Climate Change. Under the terms of the Kyoto Protocol, 192 countries have been encouraged to reduce their greenhouse gas emissions. Many of the developed nations have binding emissions reduction targets identified within the guidelines. Yet unlike the approach to the breakdown of the ozone layer, the Kyoto Protocol failed to unite the global forces in the same way against climate change. Having a global response, having a global approach to science doesn't always guarantee success. And this is one of the reasons why we've needed to look at economic impacts, political issues, and how each of those very important forces can impact on the sort of science that is done and the response to it. Thanks for watching.